In the previous lecture, we talked about the fact that everything in a computer is represented in binary. In this lecture, we'll talk about something called data types, variables, and constants. So before we move to the new material, take an in-video quiz to tell me that you remember that relationship that I gave you in huge font last time. Okay, so given that we have stuff represented in our computer as ones and zeros, how do we know how to interpret those ones and zeros? So this sequence of ones and zeros that I've given on this slide, one way to interpret it would be as 65, the number 65 using a binary. Another way to interpret it would be as capital A if we were using this ancient system called ASCII. Now we use Unicode, but ASCII was used to represent characters with ones and zeros. Or it could represent a variety of other things. It could represent the red value of a pixel. So just because we can represent things with ones and zeros, that doesn't totally solve our problem. We need to know how to interpret those ones and zeros. What do they actually mean? And one of the core things that we get in our programming languages, including C#, is something called a data type. And when we say these ones and zeros are a particular data type, that tells our compiler how to interpret those ones and zeros. The other thing that a data type tells us is the valid operations that we can apply to those ones and zeros. So for example, if we had those ones and zeros and they were an integer, taking those integer ones and zeros and adding them to true, for example, doesn't make any sense. And so data type tells us two different things. It tells us how to interpret the bits at a particular memory location, and it tells us what we can do with those bits as valid operations. Okay, so here is a conceptual picture of what memory looks like, and of course it doesn't look exactly like this, but we have a bunch of memory locations that have addresses and they have contents. There's ones and zeros in those memory addresses. It is actually impossible for a memory address to have nothing in it. They can't be empty. Remember, there are a bunch of switches. Switches are either on or off. There are no dimmer switches in our computer, so they're either on or off. So every memory location has something in it. And so they have ones and zeros as the contents of the memory location, and they have an address. Now, it would be horribly inconvenient for us to have to actually use the addresses of the memory locations in our C# source code. So we'd really like a way to name a particular memory address with a name that is meaningful to us as the programmer. And of course, under the covers, that name gets converted to the memory address that got allocated for that named memory location. But for us within our C# program, we can just refer to it by name. And so I'm going to give you an unfair in-video quiz that asks you a question that you can't possibly know the answer to yet. So go ahead and take this in-video quiz and then we'll talk about it. So the way we get a named space in memory is by declaring a variable or by declaring a constant. So let's talk about variables first. We declare a variable by putting a data type first, so that the compiler knows how to interpret the ones and zeros and knows how much memory to allocate for this particular variable. And then we put the variable name so that we as programmers can refer to that memory location by name rather than by memory address. Optionally, we can also give the variable a value when we declare that, and we'll see that when we start talking about integers in the following lecture. Okay, so what about constants? Well, constants work essentially the same way, except that we provide a data type. First, we provide a keyword, const. Then we provide the data type of the constant. Then we provide its name. And then we have to give it a value. We don't optionally give constants values. We have to give them values when we declare them. Okay, given the information that I've recently talked about, go ahead and do an in-video quiz for which you probably ought to be able to, if you don't know, you should be able to guess the answer. And of course, many answers, right? Variables are variables, constants are constant. So the big ideas behind this lecture are, we have these things called the data types, and they tell us how to interpret the bits at a particular memory location and the valid operations for those bits. That's what data types do. Variables are declared to allocate memory for a particular data type so that we can refer to that memory location by name instead of by memory address. And constants do the same thing for us, except that those are values that we cannot change as we actually run our program.